Okay, so I've got a flywheel, radius, mass given, radius gyration given. I've got a 20 kilogram block attached, right? It says determine the power delivered if that thing is moving up at 7.5 meters per second. So power is, in rotation terms, is the moment times omega. Okay, so we've got to find the moment, we've got to find omega. Let's start by taking a look at the flywheel, like so. I've got I've got a tension pulling down on here, and I've got a moment causing that to go up. Okay, so that moment is just going to equal, let me start by saying there's no acceleration, so these are basically statics problems to find these values here, right? So hopefully everyone is clear that that moment equals 0.5 times the tension, because the radius is 0.5, the tension is unknown at this point. But I know the tension is pulling up here. I've got a weight pulling down. It's 20 times 9.8, which means that tension is just 20 times 9.8, which is 196. Again, because the acceleration is 0, this is just a statics problem, right? So from that, I learned that the moment is 98. Okay, so I got a moment of 98. Now I got to talk about omega, right? So that moment is 98 omega. This thing is traveling at 7.5. Now we know that omega is just v divided by r, or I can think about v equals r omega, however you want to think about it. But that omega is just based on the velocity of 7.5 divided by that radius of 0.5, and that's really all there is to this. It's just recognizing that what I have is moment and an angular velocity. Knowing the angular velocity, knowing the acceleration is 0 makes the moment pretty easy to find, and I can find that the power input is 1470 watts. So pretty straightforward problem on this guy.